Side-scan sonar is a category of sonar system that is used to efficiently create an image of large areas of the sea floor. Uses: side-scan sonar may be used to conduct surveys for maritime archaeology. In conjunction with sea floor samples, it is able to provide an understanding of the differences in material and texture type of the seabed. Side-scan sonar imagery is also a commonly used tool to detect debris items and other obstructions on the sea floor that may be hazardous to shipping or to sea floor installations by the oil and gas industry. In addition, the status of pipelines and cables on the sea floor can be investigated using side-scan sonar. Side-scan data are frequently acquired along with bathymetric soundings and sub-bottom profiler data, thus providing a glimpse of the shallow structure of the seabed. Side-scan sonar is also used for fisheries research, dredging operations and environmental studies. It also has military applications including mine detection. How it works: side-scan uses a sonar device that emits conical or fan-shaped pulses down toward the sea floor across a wide angle perpendicular to the path of the sensor through the water, which may be towed from a surface vessel or submarine, or mounted on the ship's hull. The intensity of the acoustic reflections from the sea floor of this fan-shaped beam is recorded in a series of cross-track slices. When stitched together along the direction of motion, these slices form an image of the sea bottom within the sway of the beam. The sound frequencies used in side-scan sonar usually range from 100 to 500 kHz. Higher frequencies yield better resolution but less range. History Technology The earliest side-scan sonars used a single conical beam transducer. Next, units were made with two transducers to cover both sides. The transducers were either contained in one hull-mounted package or with two packages on either side of the vessel. Next, the transducers evolved to fan-shaped beams to produce a better sonogram, or sonar image. In order to get closer to the bottom in deep water, the side-scan transducers were placed in a towfish and pulled by a tow cable. Up until the mid-1980s, commercial side-scan images were produced on paper records. The early paper records were produced with a sweeping plotter that burned the image into a scrolling paper record. Later plotters allowed for the simultaneous plotting of position and ship motion information onto the paper record. In the late 1980s, commercial systems using the newer, cheaper computer systems developed digital scan converters that could mimic more cheaply the analog scan converters used by the military systems to produce TV and computer-displayed images of the scan, and store them on videotape. Currently, data is stored on computer hard drives or solid-state media. Military application. One of the inventors of side-scan sonar was German scientist, Dr. Julius Hagemann, who was brought to the U.S. after World War II and worked at the U.S. Navy Mine Defense Laboratory, Panama City, Florida from 1947 until his death in 1964. His work is documented in U.S. Patent 4,197,591, which was first disclosed in August 1958, but remained classified by the U.S. Navy until it was finally issued in 1980. Experimental side-scan sonar systems were made during the 1950s in laboratories including Scripps Institution of Oceanography and Hudson Laboratories and by Dr. Harold Edgerton at MIT. Military side-scan sonars were made in the 1950s by Westinghouse. Advanced systems were later developed and built for special military purposes, such as to find H-bombs lost at sea or to find a lost Russian submarine, at the Westinghouse facility in Annapolis up through the 1990s. This group also produced the first and only working angle look sonar that could trace objects while looking under the vehicle. Commercial application. The first commercial side-scan system was the Kelvin Hughes transit sonar, a converted echo sounder with a single-channel, pole-mounted, fan beam transducer introduced around 1960. In 1963, Dr. Harold Edgerton, Edward Curley, and John Yules used a conical beam 12 kHz side-scan sonar to find the sunken Vineyard Lightship in Buzzards Bay, Massachusetts. A team led by Martin Klein at Edgerton, Jamshausen and Greer developed the first successful towed, dual-channel commercial side-scan sonar system from 1963 to 1966. Martin Klein is generally considered to be the father of commercial side-scan sonar. In 1967, Egerton used Klein's sonar to help Alexander McKee find Henry VIII's flagship Mary Rose. That same year Klein used the sonar to help archaeologist George Bass find a 2,000-year-old ship off the coast of Turkey. In 1968 Klein founded Klein Associates, Incorporated, now L3/Klein, and continued to work on improvements including the first commercial high-frequency systems and the first dual-frequency side-scan sonars, and the first combined side-scan and sub-bottom profiling sonar. In 1985, Charles Maisel of Klein Associates produced the first commercial side-scan sonar training videos and the first side-scan sonar training manual. For surveying large areas, the Gloria side-scan sonar was developed by Marconi Underwater Systems and the Institute of Oceanographic Sciences for NERC. This operated at relatively low frequencies to obtain long range. It was used by the U.S. Geological Survey and the IOS in the UK to obtain images of continental shelves worldwide. Manufacturers of higher frequency side-scan sonar systems include Furuno, Sonadin, Lowrance, Simrad, Raytheon, Northrop Grumman, EdgeTech, C-Max Limited, L3/Klein Associates, J.W. Fisher's MFG Incorporated, Imaginex Technology Corporation, RESONAS, Sonatech Incorporated, Benthos, Wesma, Marine Sonic Technology, Kongsberg Maritime, Geoacoustics, EDO Corporation, Ultra Electronics, Humminbird, and Deep Vision Technologies. Shallow water side-scan systems, Tritech and deep-rated side-scan systems. See also, aperture synthesis, beamforming, phased array, Sonar 2087, synthetic aperture sonar. References. External links, Marine Sonic HDS sonar system, side-scan sonar, use of side-scan sonar to recover drowning victims, pictures and description of USGS Benthos SIS-1000 side-scan sonar tow vehicle. NOAA's use of side-scan and multibeams sonar to make official U.S. nautical charts, examples of geocoded side-scan images, a guide to side-scan sonar acquisition and processing and image galleries, Tritech Knowledge Base, side-scan sonars.